Hey folks, Mike Johnson here. If it's got wheels and an engine, you're in the right place. On this channel, we dive into car repairs, maintenance tips, and everything you need to keep your ride running smooth. If you're into cars and want to keep learning, don't forget to hit that like button and subscribe. It really helps the channel out. All right, enough talking. Let's get into it.
The smooth operation of an automotive engine depends on several key components, and among them, the mass airflow (MAF) sensor plays a crucial role. The MAF measures the amount of air entering the engine, providing essential data for the engine control module (ECM) to adjust the air-fuel mixture. However, a faulty MAF sensor can lead to a variety of problems, impacting engine performance, fuel consumption, and emissions. This article will look at the typical symptoms of a faulty MAF sensor, and explore possible solutions to these problems. Understanding these aspects is crucial for vehicle owners, enabling them to quickly diagnose potential problems and take corrective action to maintain their vehicle's efficiency and reliability. Explore with us the intricacies of the MAF sensor and discover how to identify and resolve malfunctions linked to this vital component of the engine management system. Understanding the role of the MAF sensor. How the MAF sensor works. The mass airflow (MAF) sensor is a key part of a vehicle's engine management system. It operates by accurately measuring the mass of air entering the engine. To do this, the MAF uses a C-Horft wire or thin film that reacts to variations in temperature as a function of airflow. The wire's electrical resistance is modified accordingly, generating a variable voltage read by the ECM. The importance of a properly functioning MAF sensor. A noticeable loss of power is one of the most obvious signs of a faulty MAF sensor. When the sensor is not working properly, the ECM may receive incorrect data on the amount of incoming air, which can lead to an imbalance in the air-fuel mixture. As a result, the engine may struggle to generate the necessary power, resulting in slow acceleration and a less than dynamic response to gas pedal pressure. 2. Engine misfire and unstable idle. 3. Increased fuel consumption. Suddenly increased fuel consumption is another potential indicator of a faulty MAF sensor. When the MAF provides inaccurate data to the ECM, the system may increase the amount of fuel injected to compensate for the apparent lack of air. This can lead to significant fuel inefficiency, resulting in frequent visits to the service station. Using an OBD scanner. Accurate diagnosis is essential to identify a faulty MAF sensor. Using an OBD, onboard diagnostics, scanner is one of the most effective methods. This tool plugs into the vehicle's OBD-II port, reading the error codes stored in the ECM. Specific codes linked to the MAF sensor, such as P0101, may indicate a fault. Checking MAF data on an OEM level analysis tool. To carry out this check, connect the OEM level analysis tool to the appropriate vehicle ports. Start the engine and make sure it reaches operating temperature. While driving, operate the vehicle in WOT mode. On the analysis tool, observe the MAF sensor value in real time. The WOT value should generally exceed 7 kHz. This real-time check while driving provides valuable insight into how the MAF sensor operates in real-life conditions. If the measured value is significantly lower than the expected range, this may indicate a malfunction of the MAF sensor, requiring special attention. Be sure to consult the manufacturer's specifications for your vehicle to confirm the appropriate value ranges for the MAF sensor. This ensures accurate and reliable system evaluation. Visual inspection. A visual inspection of the MAF sensor may also reveal obvious problems. Loose electrical connections, damaged wires, or dirt on the sensor can affect its operation. Cleaning the sensor can sometimes solve minor problems, but it is essential to do so with care, using a specific cleaner. When using the OBD scanner, it's important to note any error codes associated with the MAF sensor. This provides valuable information for pinpointing the underlying cause of the malfunction. Corrective measures for a faulty MAF sensor. 1. Replace MAF sensor. If the diagnosis confirms that the MAF sensor has failed, replacement is often the best solution. It is essential to choose a quality replacement sensor, specific to the vehicle model, to ensure optimum system operation. 2. Cleaning the MAF sensor. 3. Check electrical connections. Make sure that all the MAF sensor's electrical connections are securely in place. Loose connections can lead to communication problems between the sensor and the ECM. The data parameter you wish to examine is usually labeled airflow and is measured in grams per second, g/s. Here's how it works. Find the airflow data parameter ID, PID, on your analysis tool. Start the engine, bring it up to operating temperature, and leave the vehicle parked. Let the engine idle while you monitor the PID. At idle, the approximate airflow, in g/s, should roughly reflect the engine size, measured in liters. For example, if you have a 1.8 L engine, the reading should be close to 1.8 g/s. As shown in the image below, representing a 1.8 L Honda engine with a working MAF sensor, the idle reading is 2.27 g/s. This procedure enables you to quickly assess whether the MAF sensor is working properly, and to identify any airflow problems. In the event of abnormal or inconsistent readings, further checks and corrective action may be required. Note the correlation between idle airflow and engine displacement. It's important to note that the correlation between idle airflow and engine displacement is an imprecise empirical measurement that can vary from vehicle to vehicle. Some automakers include MAF sensor specifications in factory repair information. Therefore, it's a good idea to consult a repair manual or repair database for this information. This approach ensures a more accurate and reliable assessment of the MAF sensor's operation, taking into account the manufacturer's specifications. Indeed, the variability between vehicle models can make this empirical correlation less reliable. Therefore, referring to official sources such as a vehicle-specific repair manual or repair database is essential to obtain specific and accurate data concerning the MAF sensor. For this test to be useful, you must also monitor the full throttle airflow PID, WOT. Ask an assistant to drive while you monitor the airflow PID on the analysis tool, or use the tool's recording function, if available. It is preferable to view the airflow PID graphically if your analysis tool offers this capability. Ask your assistant to drive the vehicle in WOT, wide open throttle, mode. Note, it may be necessary to downshift the transmission to create sufficient load on the engine. In WOT mode, the MAF sensor reading should be approximately 40 times the engine displacement. For example, if your vehicle is fitted with a 1.8 L engine, the MAF reading should be around 72 g/s, 1.8 times 40 is equal to 72. If the engine has variable valve timing, VVT, the MAF sensor reading should be around 50 times the engine displacement. So, if our 1.8 L engine is equipped with VVT, the reading should be closer to 90 g/s, 1.8 times 50 is equal to 90. If you find that the readings are significantly below these values, there's a good chance that the MAF is dirty or faulty. You can test the MAF further using the following approaches. 5. Checking the output of a digital frequency MAF sensor. Hot film MAF sensors generate a digital waveform pattern in the form of small square bumps. The frequency of these bumps increases as the airflow through the MAF increases. To check the output of a hot film style MAF sensor, you'll need a digital multimeter with a frequency setting, HZ, an OEM, i.e., expensive, level analysis tool, or an oscilloscope. The oscilloscope is the optimal choice, as it can detect minor problems in the MAF output signal. Let's take the example of a vehicle for this test, a 1998 Chevrolet Astro with a 4.3 L engine and a MAF sensor in known good condition. Chevrolet's specifications for the MAF sensor, with the van at operating temperature, indicate a frequency of around 2285 Hz at 4 and 6 g/s. It's important to note that this value has a range and doesn't need to be absolutely exact. To perform this test, connect multimeter or oscilloscope to MAF sensor output leads. Start the motor and bring it up to operating temperature. Using the analysis tool or multimeter set to frequency, HZ, observe the MAF sensor output. The frequency of the square bumps should increase in proportion to the increase in airflow through the MAF. If you notice significant irregularities, peaks or drops in frequency that do not correspond to the expected variation, this could indicate a problem with the MAF sensor. Consult the manufacturer's specifications to confirm that the sensor output is within the appropriate range. 6. Using an oscilloscope in addition, to check the MAF frequency output, you can use a digital multimeter with a frequency measurement function, or an oscilloscope. The oscilloscope is the best option, as it allows direct visualization of the MAF signal. To set up the oscilloscope, you'll need a rear probe test lead to connect to the MAF signal lead, see photo. You'll need to attach the positive, red, wire to the MAF sensor signal wire, and the negative, black, wire to a good ground. Consult a repair manual or repair database to determine which wire corresponds to the MAF signal wire. Be sure to follow these steps carefully, and connect the oscilloscope's positive test lead to the MAF sensor's signal lead. Connect the oscilloscope's negative test lead to a good ground, usually the vehicle chassis. Switch on the oscilloscope and set it to the appropriate range to view the MAF signal frequency. Start the engine and bring it up to operating temperature. Observe the wave pattern generated by the MAF sensor on the oscilloscope. Direct visualization of the MAF signal allows you to detect anomalies or irregularities that may not be obvious in other tests. This method offers an in-depth approach to assessing the health of the MAF sensor. 7. Checking the output of a MAF analog voltage sensor, hot wire. 6. Using an oscilloscope. 8. Using an analysis tool. The typical reading for an analog MAF sensor is around 1 volt at idle. As shown in the image below, a Honda's sensor reads 1.31 volts at idle, which is considered excellent. Checking MAF sensor signal voltage with an analysis tool. MAF sensor signal voltage should increase steadily as the amount of air entering the engine increases. You can check this by monitoring the value while driving, with the help of an assistant or using the recording function, if available. Typically, at wide open throttle, WOT, or full throttle, the value should be close to 5 volts. The Civic's MAF output at idle seems correct. Open the throttle manually, or ask an assistant to operate the throttle pedal. The voltage should increase steadily as the airflow increases. This simple but effective method with a digital multimeter allows you to check the output of the MAF sensor, providing clear indications of its operation during different engine running conditions. Use this information to assess the health of your MAF sensor and take appropriate action in the event of abnormal results. Is it really a bad MAF sensor? 6. Using an oscilloscope sensor circuit check, consult a repair manual or repair database for the factory wiring diagram. Then use a digital multimeter to ensure that the supply voltage and grounding parts of the MAF circuit are intact. It is important to check continuity between the MAF sensor and the PCM, powertrain control module. PCM software update. Although somewhat rare, it is possible for the PCM to interpret the MAF signal incorrectly. The vehicle manufacturer may have issued a technical service bulletin, TSB, suggesting a software update to resolve this type of problem. Consulting the relevant TSB can provide valuable information on available software patches. By carrying out these additional verification steps, you can determine whether the problem actually resides in the MAF sensor, or whether it is linked to other circuit components. A methodical approach ensures accurate identification of the source of the malfunction, enabling targeted and effective repairs. How to clean a mass airflow sensor. What you need to clean a mass airflow sensor, and the tools and supplies needed to clean a MAF sensor may vary depending on the type of vehicle you own. In general, you'll need a clean towels, MAF sensor cleaner, safety glasses, screwdriver. Before starting the cleaning process, be sure to take all necessary precautions, including wearing protective eyewear to avoid eye contact. Carefully follow the instructions of the MAF sensor cleaner you are using. MAF sensor cleaner. When cleaning your MAF sensor, you should always follow the instructions on the product you have purchased. In general, however, the process involves the following. Warning: do not use MAF cleaner on Karman Vortex style MAF sensors. This type of sensor uses either an ultrasonic receiver or a pressure transducer to detect vortices in the airflow through the sensor. Using a standard MAF cleaner could damage these specific sensors. Consult your vehicle's repair manual to determine the type of MAF sensor installed. Step-by-step instructions for cleaning the MAF sensor. 1. Put on your safety glasses. Locate the MAF sensor. 2. Locate MAF sensor, located between air filter and throttle body. Disconnect MAF electrical connector. 3. Disconnect the MAF sensor electrical connector. Use a screwdriver to loosen the air intake duct clamps. 4. Use a screwdriver to loosen the air intake duct clamps. Remove the MAF sensor by pulling it out of the air intake duct. 5. Remove the MAF sensor by pulling it out of the air intake duct. 6. Place a clean towel under the MAF sensor. Spray the recommended amount of cleaner, as indicated in the product instructions, onto the sensing element inside the MAF housing. Attach the straw to the spray can. Attach the straw supplied with the cleaner to the spray can. Make sure it is properly attached. Spray on the recommended amount of cleaner, and then spray the recommended amount of cleaner, as indicated in the product instructions, onto the sensing element inside the MAF housing. Note: do not let the straw come into contact with the MAF sensing element. Allow the MAF sensor to dry completely. Allow the sensor to dry completely before reinstalling. Reinstall MAF sensor, and replace the MAF sensor in the air intake duct, making sure it is correctly positioned. Tighten the duct clamps. Use a screwdriver to tighten the duct clamps. Make sure they are tight enough to ensure a secure connection. Follow these steps precisely to ensure effective cleaning of the MAF sensor. Using the straw with the spray can allow targeted application of the cleaner, minimizing any risk of contact with the MAF sensor element. How to replace a faulty mass airflow sensor. In conclusion, a faulty mass airflow sensor can lead to a range of performance issues in your vehicle, including poor fuel efficiency, rough idling, and decreased acceleration. By recognizing the symptoms early, such as check engine lights or unusual engine behavior, you can take proactive steps to address the problem. Remedies may include cleaning the sensor, checking for leaks, or replacing it altogether. Regular maintenance and timely diagnostics can help keep your vehicle running smoothly and efficiently. Thank you for watching, and be sure to subscribe for more automotive insights.